Okay, so this time, after plane stress, so let's talk about plate bending. Okay, here I'll be using rectangular element. Okay, rectangular element. So what is a rectangular plate bending element? Is shown in the figure. It has four corner nodes with 3 degrees of freedom at each node. Yan, no? W means yun yung vertical displacement ng plate, no? You're now I assume lahat tayo civil engineers uh, taking up finite element. Even in undergrad, we know the behavior ng plate is para lang siyang beam, no? Na nagde-deform, therefore meron siyang corresponding displacement. Okay, vertical displacement. Now, the rotation, even sa Euler-Bernoulli beam, along from the Euler-Bernoulli beam concept, di ba, nagde-deform siya, which is in terms of V, no? Yung rotation is dV dx, no? So, ganun din dito. Kung ang displacement natin is W, that the rotation or theta x, theta y is dw dx. And then yung theta y naman, dw dy. Okay? So, ganun, no? Okay? So, kumbaga, itong discussion ng plate bending element is parang ano lang to, extension ng Euler-Bernoulli beam. Okay? Because yung other degrees of freedom natin, which is the theta x and theta y, is related sa vertical displacement. Okay? So with that, since we have 3 displacement or degrees of freedom at each node, meron tayong 4 nodes for a rectangular plate element. 4 times 3 is 12. So we have 12 independent terms for defining W as a function of x and y. Okay? Now, considering Pascal triangle, so I think you're familiar with this na. So since axial, since beam, since triangular element, nakita nyo na yun, no? Yung progression ng ating displacement function, no? We've been using Pascal triangle, no? So, kailangan natin ng, dahil 12 degrees of freedom, we will need 12 unknown constants, right? Yung alpha naught, alpha 1, alpha 2, so on so forth, until alpha 11, no? Okay, alpha naught to alpha 11, that means you have 12 unknowns, okay? Now, hence, the corresponding values for theta x, theta y are, yun nga, dw dy for theta x, dy, theta y is dw dx, okay? Yung negative is just a sign convention, no? Medyo mahabang explanation why is it negative, okay? Pero it needs, para maging consistent kasi yung curvature, no, kailangan gawing negative yung theta y. No? Kung positive yung theta x, dapat yung convention natin ng theta y is negative. Okay? Now, so kung dw dy yun, just get the derivatives of w, no? In terms of dy. Okay. I think, sige, pakita ko lang, no? How is that? Where's my pen? Okay. Okay. So, alpha naught plus alpha 1x plus alpha 2y plus alpha 3x squared. Hindi ko na kukumpletuhin, no? So, dw dy. So, hanapin natin ng ano, no? Therefore, constant to. Out. Okay. Constant tong si x. Okay. Okay, in terms of y, therefore, alpha 2. Okay, so out din to. So, kaya makikita nyo, first term natin is alpha 2, which is this, alpha 2. Okay, alpha 4x came from this, kasi sa alpha 4xy from w, constant naman ang x. Constant coefficient si x. Okay? I think you know that already. So, kung i-matrix natin itong mga to, yan, you'll get this. Okay. Okay. Now, may procedures sa triangular, hindi ko lang diniscuss, no? Nagdumiretso ng ase ko sa rectangular plate bending element. No? We can relate the unknown constant alpha to the unknown displacements here by this matrix. So, for example, no? Unahin natin explain ko lang itong tatlo. Yan, itong W1, theta X1, theta Y1. Okay? So, for example, W1, theta 1, theta X1, theta Y1. Okay? So, that is 1, okay? Kopyahin mo lang naman to, ano? This is 1. Ano ang X ni W1? Remember, si W1, ang coordinates nito ay 0, 0, 0. Right? 0, 0. So, ang X niyan ay 0. Okay? Ano ang Y niya? 0. Okay? So on so forth. Okay? Kaya mapapansin nyo, 0 lahat to. Okay? How about theta X1? This is 0, 0, 0, 1, okay, 0, ito, andito na ako. O, ano ang X ni theta X? 0, okay, that's why mapapansin nyo dito, 0 lahat, okay, so, saan ba nagkaroon ng value? Now, let's focus on W3, kasi yan yung maraming values, no? O, yan, no? W3, replace ko to, no? Gawin natin tong W3, theta X3, theta Y3. Okay? So, 1. Ano ang X ni corner 3? A, right? So, this is A. Ano ang Y ni corner 3? B. Diba? B yan, no? So, this is B. Ano ang X squared? So, this is A squared. Okay? So, kaya mapapansin nyo yung value dito, 1A, B, A squared. Okay? How about XY? So, XY niya is AB. Right? Kasi ang X niya is A, ang B niya, ang Y niya is B. That's why this is AB. What is Y squared? B squared. Okay? So, that explains, no? Yung mga values na yan. No? Kumbaga, inaano lang natin, no? Sinasubstitute lang natin yung coordinates ng mga to here. Okay? So, when you do that, ito ang matrix na yun. Take note, itong matrix na to will be what? Constant, no? Constant matrix yan, no? Full of constants yan, no? Full of numbers, real numbers. Kasi, ano yan, no? Coordinates yan. Now, this is alpha. This is alpha matrix. This is a phi matrix, and this is our displacement matrix. Now, in matrix form, in simple form, this is D equals phi alpha, right? Sorry, phi alpha. Now, alpha will now be phi inverse D. Okay? Which is this. Okay? Now, parang sa beam, sa Euler-Bernoulli beam, no? If you'll notice, this is curvature. Ito din yung ginamit natin sa beam. Same lang sila. Yun nga lang, in terms of V yun. D2V, dx squared, D2V, dy squared. Okay? So, sa plate, ganito yung curvature niya. So, it's a discussion na yan ng plates and shells. No? Okay? So, nasa separate video yan. No? So, that's the curvature in terms of plate theory. Okay? So, therefore, we need to find the second derivative of W. Ito yung W natin, right? Yan. So, find the second derivative of that. Okay? In terms of X and in terms of Y. Okay? So, alam na natin yan. Now, let's focus here. And what's the value of that? Yan. No? So, when you get the second derivative, partial derivative, okay, ito makuha nyo. No? And now, in matrix form, ito siya. Okay, therefore, the curvature is this. Okay. And, parang sa beam ulit, no? Curvature is at B phi inverse D. Right? Now, we know earlier that D is, ano dito? Phi alpha. Okay? Substitute natin yan, no? Phi alpha. D is phi alpha. Okay? Phi alpha. Yan. Okay? Okay, further, parang sa beam ulit, di ba? Sa Euler-Bernoulli beam, M moment is EI times the curvature. Okay, ganun din sa plates, no? Sa plates naman, M is, ito, constant naman to no? Constant to, D matrix. From elasticity discussion. E times, or say that is the D times the curvature. Okay, but what is curvature? That is D, B, phi inverse D. Okay, which is this. Okay, now the bending strain energy stored again from plates theory, potential energy u equals 1/2 integral of 0 to A, 0 to B, T, M, dx, dy. Okay, substitute natin. Okay, 1/2 to A, 0 to B. What is this? Ito. Okay. Ay, kulang, no? I-write ko siya. Ito. 1/2, 0 to A, 0 to B, tapos the curvature transpose, lagay ko muna sa bracket, B, P inverse D, transpose. But what is M? Ulitin lang natin to. M is D times the curvature, which is D, B, P inverse D. Okay, dx, dy. Did I miss something? Okay, wala naman, no? Now, further, parang sa beam ulit, may rule sa matrix na pag nag-transpose ka, magbabaliktad yung mga position ng mga yan, no? So, 1/2, 0 to A, 0 to B. This becomes now D transpose, P inverse transpose, B transpose, D, B, P inverse D, dx, dy. Right? Okay, so parang sa beam, ginawa natin to. Okay, partial derivatives, du, dd. So, mawawala lang. So, f equal to, mawawala ito, cross out to. Okay, this is u. Okay, if du, dd, so mawawala to, 1/2, 0 to A, 0 to B, phi inverse transpose, B transpose, D, B, phi inverse D, dx, dy. Alright? And now, gaya sa beam, F, as we know, is Ku. Or, sorry, K times D, the displacement. Displacement. And where is D here? Litan ko siya ng file, save. Oops. Oops. Okay. D is here. Yan. Therefore, what remains is our K. Okay, therefore, ito, yan is your K, which is this. Okay, phi inverse, transpose, double integral, okay, B transpose, D, D, B, B. Okay, dx dy phi inverse. Okay, so that's it. So again, phi, as I told earlier, ano yan, no? Lumalabas na to, parang constant matrix to, no? A matrix consisting of real numbers. Kasi in terms of the coordinates, okay, B is, okay, okay, so phi, alam na natin to. B is where? Ito, right? This is your B. This is your B. Because alpha is phi inverse D. Now, this is your alpha. Okay, so this is your B. So, hindi siya constant, no? Kaya siya yung kasama mo sa integration here. Okay? So, pwede mo tong i-out. Ito. Kaya nilabas siya dito. Okay? Lalabas mo din to. D is ano na to, no? Constant na yan kasi given ang elasticity, ang Poisson ratio, okay? Kaya B na lang yung natitira mong kailangang i-integrate. Okay? So, ganun ang plate bending. So, okay, so that's plate bending. So, we'll now have to solve problem. Okay, so sige, sa next video na lang yan, no?